Hello, students. A warm welcome to all of you. Now, let's begin our introductory session for final year Sem 6 paper Electronics. So, in today's session, I'll present an overview of the syllabus through this video that can outline the key topics, core concepts, and learning objectives of electronics paper. You'll understand the syllabus, you'll understand the total overview of what the topics are included in this semester. Okay, so I encourage you to watch the video attentively till the end so that it can help you gain clarity on what to expect in the upcoming weeks also. So let us approach this semester with dedication to get you a good score in your exams. So let's start. So first thing is first, don't panic by looking at the syllabus, because when you look at the syllabus it seems to be big at the first glance, but actually it is very manageable. When we break it down, the whole syllabus, when we break it down, we can see it's just a handful core ideas that are repeated in different forms. So once you stay consistent, you can score good marks in your exams, and also you can build a strong foundation for your advanced studies, and also you can understand the real world applications through electronics. Okay, so let's start. So first unit is going to be band theory of p-n junction. Okay, band theory of p-n junction. So this unit introduces the idea of energy bands in solids. Here you will explore how electrons occupy the valence band and how they move to the conduction band, and what is forbidden energy gap. Okay, and how the energy gap can decide what the material is. I mean, we know the materials are classified into three types, right? The materials are classified into three types. Okay, they're insulators, semiconductors, and conductors, right? So here we are going to learn about semiconductors mostly. So this energy gap will decide what the material is, whether a material is an insulator or a conductor or a semiconductor. Okay, so for the energy gap will decide that. Next, we can also discover the difference between intrinsic semiconductor and extrinsic semiconductor. There are two types of semiconductors, intrinsic and extrinsic. Intrinsic semiconductor, it is pure semiconductor. That means it is a pure material. It is also known as pure semiconductor. Whereas extrinsic semiconductor is impure semiconductor. While in the physics language, we say it as doped material. Okay, impure semiconductor. That means we are doping something to the pure semiconductor to make it extrinsic semiconductor. Now, extrinsic semiconductor again divided into two types, right? One is N type and the other one is P type. Extrinsic semiconductor is classified into N type and P type. So in N type, there will be extra electrons, and in P type, there will be extra holes. We'll learn all that in details. Next, Fermi levels and also continuity equation. Fermi level tells us what the energy position of electrons. Learning the position of electrons is crucial because we can understand the current flow, right? So once you grasp this, every device from a bulb to a smartphone makes sense to you. Next, we'll dive into diodes, right? What is p-n junction diode? It's the simplest but most powerful semiconductor device. So diodes allow current in one direction. Okay, diodes allow current in one direction, making them perfect for rectifiers. So what is a rectifier? Rectifier is a device that converts AC into DC, alternating current into direct current, and that process is called as rectification. So in the rectification, we'll see rectifiers, we'll see half wave rectifier, we'll see full wave rectifier in detail, and we'll also see bridge rectifier in detail, and also some Zener diode characteristics and how it acts as voltage regulator. So half wave rectifier, it uses a half cycle, whereas full wave rectifier uses full cycle. Okay, and the bridge rectifier is an efficient one. It's efficient design for powerful supplies. So Zener diode and how it acts as the voltage regulator. So in the real life, this is the foundation of power supplies. You can see every charger or adapter, laptop chargers, okay, and many electronic circuits uses rectifiers. Okay, we can understand this here. Moving ahead, so now I hope it's clear that in unit 1 you are having two parts, band theory fundamentals and diodes. Now moving ahead, next unit is bipolar junction transistor. Third part, bipolar junction transistor. In unit 2, the third part is bipolar junction transistor, which is usually called as BJT, bipolar junction transistors, BJTs. So this section helps us to understand what is PNP transistor, okay, what is NPN transistor. So what is a transistor actually? Okay, we'll learn what is a transistor, then what is PNP and what is NPN, how the current flows through emitter, through base, through collector, and also how different configurations work. So transistor operate in three different configurations. One is common base, other is common emitter, the other is common collector. So these three configurations we'll learn in detail. So each configuration offers unique characteristics for amplifications and for signal processing. It can change the transistor behavior. Next, we'll also see RC coupled amplifier. RC coupled amplifier. The amplifier means which boosts the signals across frequencies using some capacitors. So this is where you see how weak signals like microphone, it can become a strong enough to behave like a speakers, loudspeakers. Okay. Then comes the next part of unit 2, fourth part, and that is feedback concept and oscillators. Feedback concept and oscillators. Here we'll discover how feedback, what is feedback? Sending part of some output back to the input. Okay, sending some part of the output back to the input, it is called as feedback. So we will send some part of the output back to the input, which can stabilize or which can destabilize the circuits. Then comes to the oscillator parts, oscillator concepts. These are the devices that generate continuous signals without external inputs. Okay, they can generate continuous waveforms without external input signals. Now here we'll also learn the Barkhausen criteria, a golden rule for oscillators. Okay, necessary condition for sustained oscillations. Then we'll also learn about phase shift oscillator. Okay, how it uses RC networks to achieve 180-degree phase shift. The frequency of oscillation, how it depends on the resistor, capacitors, the values in feedback networks. Okay, all these in feedback concepts. and oscillator concepts. Moving ahead, so here feedback concept and oscillators, and this unit is like all about making signals more stronger and more continuous. So once you grasp one amplifier or oscillator concept, the rest are just variations, you can say. It's like learning different versions of same topics. Okay, next coming to unit 3. Unit 3, fifth part, special devices. So in special devices, we learn about optoelectronic devices and advanced transistors. In optoelectronic devices, we'll go deep about photodiodes. Okay, photodiodes, Shockley diodes, solar cells, and optocouplers. Photodiodes, they are light sensitive devices for detection applications. Okay, that can detect light. We can use it in TV remotes and many more applications are there. Next, solar cell, which converts sunlight into electrical energy. Okay. Next, optocouplers, it transfers signals. They use light for it. Okay, light transmission, electric isolation using light transmission. So for the real life application, you can see automatic street lights. We can see the street lights now, and the solar panels. They can be set as direct applications. Now coming to advanced transistors, FET, we learn about FET, we learn about UJT, and we learn about SCR. FET, field effective transistors, field effective transistors as voltage controlled amplifiers. They act as voltage controlled amplifiers. And UJTs, they are used in oscillators. Okay, they act as oscillators. SCR, they act as powerful switches in industrial electronics. Okay, like they can be used as on or off buttons for heavy machines. So this unit is going to be very interesting because it's about the special devices, special purpose devices. So you'll enjoy while learning this because it connects directly to the real world gadgets. Okay, like from solar panels to a very heavy industrial machine. So it's quite interesting unit. Then comes unit 4, digital electronics. Okay, so here we learn binary system, binary arithmetic, some math included here, and some conversions, hexadecimal system and all. So binary means the system which includes 0 and 1, right? So decimal, hexadecimal system will practice conversions, binary arithmetics using ones and twos complements. Okay, this we can say this is the language of computers. So every app that you are using now, that will be that's running on the binary system only, right? So all these conversions we learn here. Next, coming to the last part of unit 4, that is logic gates, right? Logic gates, the building blocks. Here you are having basic gates like or, and, not. Okay, they are foundation of digital logics. You'll learn the truth tables. Next, you'll see universal gates, which are NAND, NOR gates. Okay, and Boolean functions. So these are the universal gates. Next, XOR, and we'll also learn about De Morgan's laws, which helps simplify logic expressions. So, talking about the real life applications, we can say every calculator, any processor, or a smartphone chip is also built from these gates only. Okay, this is also going to be fun part. We can finally see how computers think. Okay, so once you master binary and logic gates, you'll feel like you can peek inside the brain of the computer. It's very easy and interesting. So that's it about the syllabus overview. Now you know the pattern of the paper, right? Your paper is of 100 marks, in which 80 marks is for external examination and 20 marks is for internal assessment, right? So moving ahead, what are the learning outcomes? I mean, when you complete this, all the chapters, all the 4 units, which are very focused and very connected units, so the result you'll find in yourself is that you can master the semiconductor topics. You'll understand all the band theory, diodes, transistors, okay, what not, the complex electronic circuits, how they enable, how can we analyze, everything you will master about the semiconductor. Next, you can also learn the skills of circuit designing, okay, amplifiers, oscillators, feedback system, okay, oscillator concepts, and how the practical applications are there. All these you can learn. Next, you can also have the proficiency in digital logic, okay, about the conversions of number system, about the logical gates, and about the Boolean algebra for digital system development. And when we do practicals, when we do a hands-on experience, you can learn how to build the circuits and verify the theoretical concepts with the practical ones, right? So here I can say that there are only 4 units which are very focused and which are very connected to each other. So these topics are very fundamental. They're not very advanced level. So once you understand the semiconductors, the rest can flow very natural. So the topics are very conceptual and repetitive topics only. No need to memorize anything here. Okay, you don't have to memorize anything. You don't have to do big derivations like in other semesters. Okay, nothing math derivations, not much maths is included. Just not memorizing, no derivation, no mathematical concepts, just the concept, understanding of the concept is there in this sem. That's it. So moving ahead, so I can say that your journey in electronics begins here. So you should be ready to excel. So after completing the electronics or after completing the SEM 6, I'm sure that you can master the fundamental concepts. You can develop the problem solving skills. You can get good score in your exam, okay, and you can also be ready for your advanced studies, because this electronics here, the it acts as a basic for your advanced studies, okay. If you're going to take MSc electronics or MSc physics, it will stand as a basic. The electronics is very important paper. So this is the total overview of the syllabus. You can take the screenshot. So as I said, electronics is not just about memorizing. It's about understanding, like how signals flow, how devices work. Once you see the logic, everything will be easy for you. So I recommend you to be consistent so that this semester will go smooth. So you can also prepare for your exam, as I said, and you can also understand the technology that powers the world around you, right? So I hope you understood the total overview of the syllabus. Right? Thank you. We'll meet in the next video. Thank you.